Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss the pure inductive AC circuits. So first of all let me tell you that what is a pure inductor. We have already discussed the pure inductor in the videos of electromagnetic induction. But let me tell you again that you know that when we shape a wire in form of a coil, then that wire have inductive properties, as well as we know that that wire will be definitely having some resistance, because there is no conductor which does not have any resistance. So each conductor will have some resistance and therefore when we shape a straight wire in the form of a coil, in the shape of a coil, then that coil has the resistive properties also, as well as inductive properties also, and that is why we say them as an impure inductor. But pure inductor does not have any resistive properties, which means that it only have the pure inductive properties, and this kind of uh, resistance, this kind of inductance is not possible, because you cannot remove the resistance part of a wire. So this pure inductor is only, I will say, a theoretical concept. It is not a practical one. Okay, so let us discuss the pure inductor in the AC circuits. So we have connected this inductor with a alternating AC source, you can see, and let's suppose that at any time the polarity of this AC source is this one, and therefore as we can see that inductor and this AC source are in parallel to each other, therefore we can say their voltage will be equal in magnitude and the polarity, and hence we can say that the voltage across inductor is L di by dt, and it would be equal to V naught sine omega t. Now di will be equal to V naught by L sine omega t dt. Now integrating both the sides, and we are not putting the limits, we are doing an indefinite integration. So it is I will be equal to minus V naught by L omega cos omega t and plus C, where C is the constant of indefinite integration. Now let us talk about the value of C. You can see that according to dimensional analysis, this thing is current, and hence this complete term will be representing the current in dimensions, and therefore the dimensions of C will also be of the dimensions of current. So we can say that C is dimensionally having the dimensions of current, which is A1 T1, and we can definitely say that C is a constant quantity. So C will be a DC current, because C is constant in magnitude as well as in sign. So C will be definitely a DC current, and we can say that the value of C will be 0, because there is no DC source in the circuit. The source which we have connected in the circuit is only the AC. So we can say that the value of C will be 0, because there is no DC source connected in the circuit. Okay, now we can substitute the value of C, and we can write down I as minus V naught by omega L cos omega t. Now let us talk about this thing. Now, as we know that it is the peak value of current I naught, and it is V naught by omega L, and this thing which is dimensionally equal to the resistance is called as XL. This thing is called as XL, and XL has a name of inductive reactance. This is inductive reactance. And we can say that inductive reactance is the resistance offered by a pure inductor to the AC current. And the value of XL is omega L. And high frequency circuits, for high frequency circuits, XL is large, and for low frequency circuits, XL is small. Okay. And the second thing, which is very important to note, that for DC, as we have already discussed, that for DC current, omega is 0. And therefore, XL will be 0 for DC currents, which means that inductor does not offer any resistance to DC currents because inductor gets short circuited in DC circuits. We have already studied this concept in LR circuit, that in steady state inductor gets short circuited. So for DC, the resistance offered by pure inductor is 0. And now if we talk about the current, so current is I is equal to I naught minus I naught cos omega t. Now if we write it down as I naught minus I naught sine pi by 2 minus omega t, if we write it down as this one. So I know that you must be thinking that why I have not written it as sine pi by 2 plus omega t. Because in that case, if this negative sign would go inside this trigonometric function, that then in that case omega would become negative. If I would have written this as pi by 2 plus omega t, which is trigonometrically correct, but if this negative sign will go inside that function, then omega will become negative, which is incorrect because we cannot give omega a negative sign because originally omega has a positive sign. Okay, so we cannot use that negative sign with omega. So I have written it like this. Therefore, it becomes I naught sine omega t minus pi by 2. And you can easily see that if we write down the voltage here, it is V naught sine omega t. So we can definitely say that in pure inductive circuits, voltage leads the current by pi by 2. Voltage leads the current by a phase of pi by 2. And if we draw the phasor diagram, you can see that at t is equal to 0, we can say that the initial phase of voltage is 0. So I can write down the voltage on x-axis, and obviously the current has a initial phase of minus pi by 2 at t is equal to 0. So I'll be drawing the current on the negative y-axis. This phasor diagram clearly represents that current is behind the voltage by pi by 2. And if we draw the wave diagram, so if we draw the wave diagram, then wave diagram of voltage will be a sinusoidal curve. This is V naught, this is minus V naught, and the wave diagram of current I will be a cos curve but with a negative sign. So this will be the wave diagram of current. So it will be a cos curve. So this will start from minus I naught and this is plus I naught. So it will go like this. Okay, so this is the graph of pure inductive circuits. Now, if we talk about the power and power factor. Now, power factor, as we know, is cos phi, and it would be 0 here because phi is pi by 2. Plus or minus pi by 2 doesn't matter because cos phi is 0 for both of them, and the average power loss in the circuit is 0, which is so obvious because we have already discussed that capacitor and inductor are the devices which are used to store the energy rather than losing the energy. And we have already discussed that there is no resistance present in this circuit, so there will be no loss of heat in this circuit because there is no resistance. And as there will be no heat loss, the average power loss will be zero. And inductor will be storing this energy in the form of magnetic potential energy, and this energy will be stored inside the inductor in magnetic field. So guys, thank you. In That's it in this video, and in the next video I'll be bringing the combination of circuits. Thank you.